So, Dominic, welcome to the channel. Make cancer metabolic, not genetic. So, when did you first come across Professor Seyfried's work?
Yeah, I came across his work in 2008 or 2007 or 2008 when we started doing work on different cell lines, including in 2004, I started working on a brain tumor cell line. And I was using it because brain tumor cells are incredibly easy to grow. And I was just doing some simple cellular biology on looking at the effects of high pressure oxygen on different types of cells. And neurons are quite hard to grow. So cancer cells are easy, muscle cells are easy, human dermal fibroblasts are easy. And then ultimately I started studying neurons, and I observed that when you expose cancer cells to high levels of oxygen, that they overproduce oxygen free radicals and they die significantly faster than like a healthy cell. So that was interesting to me, but I was not a cancer biologist at the time. And then we developed some unique technologies in our lab, including hyperbaric microscopes, where we have, for example, an atomic force microscope or a laser scanning confocal microscope inside a hyperbaric chamber. So this allowed us to look at the mitochondria. And what I observed was that the mitochondria were literally exploding or rupturing under high pressure oxygen, and the cells were dying faster than normal healthy cells. And I became increasingly curious as to why that was happening, although it was not part of the project that I was funded to do. I was contracted by the Office of Navy Research to find out the cellular mechanism, and also ultimately a mitigation strategy against oxygen toxicity, which is experienced by Navy SEAL divers and other divers that use closed circuit rebreathers. So to figure out why my cells were dying, I did a PubMed search and started pulling different, publications out. And ultimately, I stumbled across a couple publications that were very interesting to me. And one was Dr. Thomas Seyfried. And I reached out to maybe about 4 or 5 different people. Some people were at the Moffitt Cancer Center, which is the largest cancer center in the Southeast. It's a short walk from my lab. And
Right.
And they were actually very interested in it too. And there was a person there, Dr. Gillies or Dr. Gatenby, and he had done some work in hyperbaric oxygen. And he was very interested because the efficacy of radiation therapy is proportional to the oxygen concentration of the tumor. So he was sort of, kind of interested in this idea of enhancing the standard of care. But what Thomas Seyfried was telling me was quite different. It was that I was observing mitochondria in cells that were damaged. And because the mitochondria in these cancer cells were damaged, they were overproducing oxygen-free radicals. And biochemically, this made a lot of sense. And what was very interesting to me is that this alteration in mitochondrial function was something that you could exploit with hyperbaric oxygen or oxygen-free radicals to kill the cells. And no one had seen that before, because no one had put, this type of microscope or any microscope inside a hyperbaric chamber and image living cells with it. So that got me to, email him. And then I think we had I called him at his office, and he told me about the Warburg effect. I'd never heard of the Warburg effect. This is about 2009, maybe eight or 9.
Right. So that's pre his book.
Yeah. And then it all just kind of, I received a little bit of startup funding from my position, my transitional position into a tenure track professorship at the medical school. So I had a little bit of money, and I had a PhD student come along whose father had brain tumor, and she was very motivated to study cancer. And what we were able to do is actually work with Dr. Seyfried. I begged him for his brain tumor model, but he sort of wouldn't. He pushed back on that and was not going to give me his brain tumor model. He had a model of aggressive metastatic cancer. And the pitch to me was like, if you can, go work with this model, and if you could solve cancer in this model, you basically cure cancer, because it's, people don't die of a tumor per se, unless it's, a brain tumor pushing in on your brain. Generally speaking, people die of metastatic cancer. And he had developed a very remarkable model of metastatic cancer, and we were able to get the cells, which are transfected with sort of a bioluminescent signal that allows us to track the cancer cells once we implant them into this animal model, the VMDK model. And that became the basis of probably about 4 or 5 publications out of our lab, looking at ways to mitigate metastatic cancer with ketone metabolic therapy, supplemental ketosis. We did studies with metformin and DCA. We did, we looked at cancer cachexia, because a lot of people who succumb to dying of cancer die because of the rapid muscle wasting and inflammation that occurs from that. So we were able to take his model, which I believe is probably the best definitely the best metastatic model out there, and validate the metabolic theory of cancer. And I was very skeptical in the beginning, but what I was reading made a lot of sense. But information I was getting from other people did not completely align with what Dr. Seyfried was saying. But experimentally, when I did the experiment and I looked at the cells, it was sort of validating this. So I was always taught that cancer was a genetic disease, but the more I looked into it, it's very clear that, and I never really got too far into the argument of the origin of cancer being metabolic or genetic. And I still, to this day, I do believe that the primary driver of, and I've been giving several talks on this, the primary driver of cancer is disrupted metabolism, mitochondrial function. But I do think it's a synergy between, metabolic, genetic, and epigenetic. But I do think that disrupted metabolism is a major driver for the reactive oxygen species and the inflammation and the oncogenic transformation that then contributes, to a normal cell converting to a cancer cell.
Yeah. You were mentioned in the Press Pulse paper. So was that all part of that?
Yeah. So we were very motivated to not work with chemotherapeutic agents. Just logistically, some of these things are, you don't want to get them on your fingers. And working with radiation was also, I'm still interested in working with radiation, because we do research with NASA on galactic cosmic radiation and, DNA damage and things like that. And I believe that even going to space, and there's publications to support this, the biggest hit is on your mitochondria. So we need to protect our mitochondria when we go to space. So I do have an ongoing interest in radiation, but working with radiation is very difficult. So my mentors, and I was always taught that when you go into a field, the biggest thing to ask is, when you're done with your career, did you ask the right questions? So, and I took a step back and I was studying something very specific, CNS oxygen toxicity. And I had the ability to start researching cancer, specifically cancer as a metabolic disease. And, and just philosophically looking at, my life and looking at the trajectory of where my career was going to be, I realized that I didn't want to spend 20, 30 years studying something that's not going to make a big impact. So I was asking myself, the most important thing for young scientists to do is to pick the right questions. You don't want to spend your entire career studying the wrong questions. So Dr. Seyfried was basically, he had the most important question. That was
is
looming.
It a genetic disease, or is it a mitochondrial metabolic disease?
Yeah. And, and I think it could be maybe a hybrid of both, but I think research is ongoing, but I think the data and the evidence is weighing in his favor in many ways. And I think that was the most important, question that I wanted to put my career into, and also you want to pick mentors very carefully, and you want to pick mentors that have the vision, that are innovative, and not just, following the academic path to check the boxes, to survive in academia. It's hard enough to survive in academia. It's difficult to survive in academia if you pick questions that make it hard to get funding. And Dr. Seifried, warned me of this in 2009 and 10. Is like, you got to think about your career. You're just entering a tenure track position. Like, you don't want to. I'm a full professor, tenure professor, and so I was even told that it was academic suicide to do it. So what I've done, I've always kept one foot in the door of military research with Department of Defense, because we develop ketogenic, mitigation strategies that are extremely helpful for military operations, performance, resilience, things like that. And it's very exciting that those very things have tremendous application in Dr. Seifried's theories that he's sort of building off and correcting and advancing the science and the application of targeting the Warburg effect. And that was what I felt was probably one of the most important questions that I need to allocate my time into, and my students' time. So the biggest way I can contribute is to sort of indoctrinate, if you want to use that, students into thinking outside the box and recruiting them into the lab to do innovative science that breaks down barriers and helps to get more research to support this, or not support it. So, there are some cancers that are not, remarkably responsive to metabolic interventions that kind of fit this paradigm, but they tend to be more indolent cancers that don't grow. It's stated another way: cancers that are very aggressive, that grow rapidly and proliferate rapidly, are highly responsive to metabolic interventions. So, and I think that's what we wanted to put our time and energy into. We didn't want to put our time and energy into studying, a slow growing prostate cancer or thyroid cancer. We wanted to study glioblastoma. We wanted to study aggressive metastatic cancer, because the standard of care does not work for these cancers at all. So that's what we wanted to allocate our time into. And hyperbaric oxygen, off the shelf metabolic drugs, metformin, DCA, lonidamine, 2-deoxyglucose, sodium phenylbutyrate, targeting glutamine with that, and ketone supplementation too, exogenous ketone supplementation, where you can titrate these agents in to move your glucose ketone index into that therapeutic range and keep it there. So I saw that there was tremendous opportunity to add innovation to this field when it comes to the science and the application of these metabolic therapies.
Yeah. Just going slightly off topic, from just when you mentioned space, I watched this morning the SpaceX first spacewalk of and absolutely blew me away. But back onto the subject in hand. Did you, the latest paper that's due out, it's under review at the moment. Are you mentioned in that paper? Have you been involved with the whole writing of that?
Yeah, I think maybe you're referring to, we've published quite a few papers with Dr. Seifried, and we have a couple in the works too, but you're talking about the big comprehensive review that lays out. Yeah. So that has been a work in progress for maybe about 2 or 3 years now, going back and forth. And I think there's about 40 authors on that paper. Yeah, and I've reviewed it. I've put my feedback into it. I've changed sections, associated with ketone supplementation and hyperbaric oxygen, and I think it's going to definitely impact the glioblastoma treatment. I think it has that ability to do that, but I think it can also be applied to other cancers. So, which is important, because brain tumors are relatively rare compared to other tumors. And I think, but that is that's almost like the proof of concept proving ground for this. But cancers are, there's a lot of, there's tremendous heterogeneity in cancers, even from a metabolic perspective, I think. I mean, I think they all have a metabolic, we can, for the most part, especially if the cancers that are going to kill you, you can, targeting the Warburg effect will have a therapeutic response. In some cancers, it'll be tremendously effective, and in other cancers, it will just gradually turn down their growth rates. But I think it is super important also to target glutamine. I know Thomas Seifert is, focusing on that. I have not worked with Dawn, but I have worked with other, glutamine targeting agents in the lab.
Yeah. Have you seen the video on my channel or elsewhere with Den Stacey?
No, I have not.
Dennis Stacey.
Yeah.
Dennis Stacey is N of 1, and he worked with the Hippocrates Research Foundation and did a whole protocol. And on my website, I do have a copy of his paper that the Hippocrates released. And he's now, he had arterial sarcoma and was sent home to die. And he's now no evidence of disease. And he did the full press pulse protocol, complete with Don and I mean the papers on my website. But yeah, so in Dennis Stacey's words, it works. It really works. And when you understand the science and the science behind it, you can understand why it works. And these things blew me away. And when I realized that the whole cancer industry is basing their therapies on a flawed, shall we say, theory, it just blew my socks off. And that made me determined to share the work of Professor Seyfried and yourself, whilst ever I can draw breath, because it's just, according to Cancer Research UK, the largest cancer charity here in Britain, who raise £420 million a year, wearing pink and running around parks and stuff, and they are looking at everything that's dependent on gene mutations, and it's just 420 million, and it just beggars belief. And they reckon that 10 million people a year will die worldwide of cancer, and we have to do what we can, and this is my
prevention. I just gave a lecture. Our medical school has a mandatory, now it took quite some time, mandatory course in nutrition and metabolism. And the paper recently came out. It's called A Cancer Journal for Clinicians. It's the flagship journal of the American Cancer Society, which has not always, now they're very interested in metabolism, because the title of the review that came out that really supports Dr. Seyfried's theory, I think, because 50 years ago, they did not even look into nutrition and metabolism into cancer. So 50 years ago, it was completely genetic, right? So the title of this paper, and it used data from 2019, because it takes 5 years to write these kinds of papers. The impact factor of this journal is 508. So I don't know if that might not mean too much to your listeners out there, but if I get into a 5 or 6 impact factor for a nutrition journal, like, I'm super happy about that. So an impact factor of 508 means that this work gets cited a lot and it's accepted among the world of science, right? So the title of this paper is Proportion and Number of Cancer Cases and Deaths Attributed to Potentially Modifiable Risk Factors in the United States data. This data was collected. It's one of the biggest studies ever done from 2019 data. So the authors conclude that 50% of all cancer deaths in the United States are attributed to modifiable risk factors. And of the risk factors, the top 12, 9 of them are intimately tied to our nutrition and metabolism. So the first one is, it's cigarette smoking. So that has gone down tremendously, but excess body weight, lack of physical activity, just dietary patterns, high carbohydrate intake, all these things are the things that were contributing, to cancer. So now big reviews like this that get cited especially start to influence the National Cancer Institute and NIH to start allocating more money into hopefully nutrition and metabolism, but there's not a whole lot of research dollars for nutrition. So what's going to happen is that there's pharmaceutical companies are going to start targeting metabolic pathways that are just directly and easily targeted with nutritional interventions. And that's okay because we can develop, comprehensive nutritional protocols and then add on various metabolic targeting drugs as pulse protocols, in our concept, the press pulse concept that you mentioned. But I think that's important to know because people do not know that 50% of cancers are associated with modifiable metabolic risk factors.
Yeah. As the professor always states on his videos, diet and lifestyle, and if people wanted to prevent cancer, we wouldn't have an obesity epidemic in the United States. And whenever the United States sneeze, Britain catches a cold. We're just 5 years behind you.
Yeah.
And you only have to look on the high street, with the numbers of fast food restaurants and you name it. I mean, anything you can get in America, you can almost get here. And I think if you wanted to make yourself rich, find the latest fast food craze that's in America that's not here, and bring it here as a franchisee is one thing. So when is the best time to implement HBOT in press pulse metabolic therapy?
Yeah, that's a good question. I think we looked at hyperbaric oxygen as a standalone therapy in the metastatic model, and we always saw trends for, I think, the overall, if we looked at the trend, it was approaching about 20% increase in survival with a standard high carb diet with hyperbaric oxygen. But then we got, exponentially greater tumor suppression and extension of survival when we coupled that with ketone metabolic therapy. So the most important thing to do from our perspective is to achieve and maintain a glucose ketone index of between 1 to 4. And I think, Tom Seaford may have tighter regulations like 1 or 2, but I think even achieving a glucose ketone index of 4 or 5, especially for someone who's very insulin resistant, the average American has a glucose ketone index of 25 to 50, right? So bringing that down to 10, and then bringing it down to 5 is going to represent a significant shift in metabolic physiology and the drivers of the Warburg effect, which are not only glucose. Everybody focuses on glucose, but it's glucose, it's blood levels of insulin, it's inflammation, it's reducing triglycerides. Things like HSCRP need to be measured. It's looking at and ensuring that you have, adequate levels of B12, of other factors. So there's like a suite of different metabolic markers that we measure that, and then the same markers are also super important for, it's insulin, HSCRP, hemoglobin A1C, trigs. Interestingly, LDL, if LDL is low, that actually makes you more vulnerable to cancer, or low LDL and low ApoB is associated with people. And that could be because when you have cancer, and I've looked at blood work from so many patients, LDL falls tremendously because the expanding biomass of the tumor maybe is using the LDL. There's something going on there we don't really know, but it is something that, I think people, ApoB is a better marker for atherogenic health, but you don't want really, really low levels because, or if you see that and you're managing cancer, that could be an issue. It's a whole nother story, and people are kind of looking into it, but there's different cancers. So at this point in time, every approach is going to be a little bit different depending upon the cancers. So colon cancer, for example, no, let's pick liver cancer. So the rates of liver cancer of all the cancers associated with poor metabolic health, obesity, type 2 diabetes, liver cancer is 3 times higher than it was in 1980. So we have a ubiquitous problem of the non-alcoholic fatty liver disease, and the liver is probably the most important organ in this conversation because it regulates blood glucose, it regulates ketogenesis, and also the liver is, when you have colon cancer or lung cancer or other, especially colon cancer, you have, if you die of these cancers, you generally die of it metastasizing to the liver. So the liver is an extremely fertile ground for the cancer cells, the circulating cancer cells, to find a home. And that fertile ground, especially if you have a fatty liver or you're following a high carb diet, which the liver sucks up glucose, stores it in the form of glycogen, it becomes an extremely fertile ground for cancer to grow. However, if you're on a ketogenic diet, your liver is depleted of glycogen. You've metabolized all the fat out of it. The inflammation in your liver is low, and that becomes almost like a desert to try to grow cancer cells in that environment relative to a high carb diet that's also, surplus amount of calories and inflammation and things like that. So I think that's important. And we see that reflected tremendously in Thomas Seyfried's animal model. So the liver looks like it's really gruesome to look at. You see all the metastasis in the liver, and that's when you inject the cells into the flank of the animal. The first thing that the cells do, they get in circulation, they go to the liver, and then the liver just explodes with tumors. And then from there, it kind of migrates to the other, and you can even have brain metastases. So keeping the liver healthy, is the utmost important thing. And how do you do that? Caloric restriction, fasting, and coupled with the ketogenic diet,
and quit the booze. Yeah.
Yep.
Yeah. Yes. You chat with Jason Watson last week.
Jason, we had a great conversation. Yep.
Jason's been on the channel and a great warrior. He was sent home to die. And he was saying that the professor recommended 3 times a week for HBOT. I mentioned to him that it may be preferential for him to go 3 times a week as opposed to 5, and that's one of the. I've got a forum on the website, and I asked on the forum of the users any questions for you, and that one came up more than anything. HBOT and how often.
Yeah. Before we chose that 3 days per week protocol, I looked at all the available literature on hyperbaric oxygen in the context of humans, which there was very little on cancer at the time, 2009 and 10, and then also in animal models. And I found some of there was a couple studies that had done the 3 days a week. And then from my understanding, and just from the perspective of favorable adaptations to hyperbaric oxygen in healthy cells, they need a gap day to recover. I think, especially in the context of an older patient who may be compromised with cancer, the favorable adaptations to hyperbaric oxygen that would prevent CNS oxygen toxicity and prevent pulmonary oxygen toxicity. It was a more conservative approach, but also to transition, because in the US, it's sort of 5 days a week, Monday through Friday, kind of, and
Yeah,
there's
yeah.
not, the protocol was kind of ambiguous. I don't think, no one had studied different protocols, but my rationale was to hit it really hard on Monday, 48 hours, let your body rest and recover. And then you hit it again hard on Wednesday, rest and recover, hit it again. And those relative changes, allowing the reactive oxygen species to go back down the baseline, which it doesn't have a complete time to do that if you do it 5 days per week every day, allowing the reactive oxygen to go down the baseline, and that relative burst in reactive oxygen species that would occur after 48 hours can, I think, be more, and logistically too, if someone's, as a patient's going to follow this 5 days a week or 3 days a week, that's 2 extra days. And then there's also the question about the level of oxygen that we use was 2.5 atmospheres of oxygen, which is quite high, but can be achieved in a hard shell chamber that's used in most clinics, for example, for wound healing. Theoretically, if we're talking about the dose of oxygen, you could achieve the same dose at a lower pressure if you increase the time in the chamber. So the oxygen dose, oxygen is a drug, and the dose is dependent upon the barometric pressure, the oxygen concentration, and then the frequency, right? So you could extend the time in there to, conceivably, 90 to 2 hours, 120 minutes, but it would be important to stay within the Undersea and Hyperbaric Medicine Society guidelines, UHMS guidelines, or the medical community guidelines. Because if you go beyond that, then you run the risk of pulmonary or CNS oxygen toxicity. That said, the whole idea behind ketosis for hyperbaric oxygen was to protect your brain, and to make a limitation of hyperbaric oxygen therapy is oxygen toxicity. And my whole career has been spent to develop ketogenic strategies to extend that. And in animals, we can extend that 600% if they're in ketosis. So what hyperbaric oxygen therapy, what ketone metabolic therapy does is make hyperbaric oxygen therapy extremely more safe. And it also makes it more lethal to the cancer, because you're reversing tumor hypoxia, hyperoxygenating the tumor, driving oxygen through a disrupted electron transport chain that overproduces superoxide. And then that precursor oxygen free radical then becomes a molecule that can convert to other damaging molecules like hydroxyl radical in the tumor. And because of the presence of much higher levels of iron, it drives certain reactions. And I don't want to get too much into the biochemistry weeds, but it drives things called the Fenton reaction. And it stated another way, cancer cells are selectively vulnerable to hyperbaric oxygen induced oxidative stress. And that's sort of the whole idea. And then ketone metabolic therapies reduce certain pathways, and I won't go all into that, associated with the pentose phosphate pathway. It kind of cripples the cancer cell's ability to defend itself while you're simultaneously jacking up the oxidative stress, in the cancer cells. So that's sort of that's what we saw essentially in our model systems. And then, I asked the question, I was like, why aren't people doing this? And then, so let's do a proof of concept in an animal model. And then it worked remarkably well. So, but pretty much every cancer biologist, if you sat down with them and explained it based on the literature, they would agree 100%. So what we're talking about here is not even controversial. And then hyperbaric oxygen is actually used in the context of cancer, but for radiation necrosis to help normal tissue repair. And in my early years as a postdoctoral fellow, I would go to and see these case reports of the patients specifically using hyperbaric oxygen for radiation necrosis, and they end up doing so much better. And it was like a remarkable recovery, but no one was thinking about it as a hyperbaric oxygen, contributing to as an anti-cancer approach.
Right. Yeah. Yeah. One of the questions that came out a lot was also that people can't get hold of, or they can't get a high pressure chamber like 2.5 atmospheres or more. not unless it's in a hospital setting or something like that. And the question came out a lot about a much lower HBOC chamber. I mean, you can buy them. I've seen that you can buy them online. There's companies here in the UK selling them, but they're down like 1.3 atmospheres, 1.5 atmospheres. So would, given what you've just said there, someone that bought a chamber for home that was 1.5 atmospheres, for example, would need to stay in there 2 hours, 3 hours, or whatever to get the same efficacy as an hour in a 2.5 atmosphere chamber.
Yeah, I would hesitate to give recommendations, but in theory, as long as you're staying within the hyperbaric guidelines, so instead of 1 hour at 2.5, atmospheres of oxygen, 2 hours at 1.3 or 1.5, according to the dive tables, or according to what I know, should be within the realm of acceptable. And especially if that's done, every other day. So it's like, you're giving that bigger hit. And then there's different ways to sort of augment that too. There's, or the oxidative stress. So we think about it as oxidative stress therapy, just that radiation is oxidative stress therapy. And most chemotherapeutic agents, their mechanism of action is to create oxidative stress, to kill the cancer cells. That's how they work, and also stopping replication, obviously. But yeah, so in theory, you could extend the duration. And then some people also asked about the frequency, doing it more frequent. And even some patients asked me, hey, can I do it morning and night? And
Right.
the short answer is that we don't know. And also your ability to be resilient in response to hyperbaric oxygen therapy, it will be dependent upon the person. So a healthy young person, the favorable adaptations happen very quickly. But if you have an older person, especially an older person with a compromised immune system, their physiological response to high pressure oxygen, which is a very big oxidative stress hit to the body, is going to be significantly different than a younger person. And also, if you have a brain tumor, you are theoretically more susceptible to oxygen toxicity seizures. So I think anyone that's battling a brain cancer that wants to use this approach, and in the US, if they've gotten radiation therapy, actually it's FDA approved, because that's one of the FDA approved the insurance will cover it. So I'm in communication with quite a few people that are using ketone metabolic therapy and hyperbaric oxygen therapy with the standard of care, including radiation. And because they've had radiation, then their insurance covers it, because that is FDA covers radiation necrosis. So they could write it in under that. Not that radiation, not that I'm in favor of radiation, especially for brain, but, and actually for some cancers, targeted radiation can be efficacious. So one of my first, before I met Dr. Seifrid, the first project that I wrote up was chlorotoxin conjugated radiation nanoparticles that would be, so basically putting a substance into the body through IV or oral that has a very specific molecule called chlorotoxin. It's from scorpions, actually. And if you attach a nanoparticle radiation that gives a burst of radiation over 24 to 48 hours, but then decays and it's completely harmless. If you were to consume that, the chlorotoxin, very interestingly, it's one of the things that grabs onto a glioblastoma and no other area of the body. So you can consume this, and if it had a radiation probe, or if it had a bioluminescent probe, it would light up the brain tumor. So we could use that molecule to site specifically deliver small amounts of radiation that would decay within 24 hours. But then you take that patient and then put them inside a hyperbaric chamber. So you're delivering site specifically the radiation. And then instead of beaming radiation, whole brain radiation or beam radiation, you would put the patient inside a hyperbaric chamber, and then that would synergize, with the radiation. But That was my first idea, maybe 2008 or 9, and we didn't get funding for that project, and I'm kind of glad we didn't, because I then learned more about the effects of radiation, the collateral damage it does, and things like that, and realized that that sounded like a very innovative approach, but I think there are equally as innovative non-toxic approaches that can be done. And then so we wanted to allocate our time and effort into non-toxic metabolic based therapies with hyperbaric oxygen.
Absolutely, yeah. I mean, I've edited so many videos of Professor Seyfried talking when he
Mhm.
talks about brain radiation and the fact that no one should ever have their brain irradiated, and
Yeah.
his opinion was that it frees up the two fuels to fuel the beast, glucose and glutamine, and
Yep.
and the cancer goes crazy thereafter, and then
Yep.
coupled with that, their face swells up, moon face, and then they end up with
Yeah.
high dose steroids, which also feeds the tumor, and it's no
Yep.
wonder that the patient dies within months.
Yeah. I would like to add that Dr. Adrian Scheck has shown that did a number of elegant studies in one in a a glioblastoma model, 262, GL262, I think, and basically showed that she could eradicate and cure glioblastoma with radiation, but only if it was coupled with a very calculated ketogenic diet. And I think she might have used a 5-to-1 ratio or 4-to-1. So it was a very extreme ketogenic diet. So in that case, you have a standard of care that does more harm than good, but then you have a standard of care therapy if it's coupled with a very comprehensive metabolic based therapy. Then it could cause a therapy that could otherwise do more harm to be efficacious. But in the brain, yeah, radiating in the brain is tough. I mean, there's certain areas that could be radiated. There's like brachytherapy, I think, for like the prostate, where you can put some beads in and then, radiate. And then if you're very aggressive with dietary therapies and things like that, you don't get collateral damage. But the radiation, I'm on the fence about it. Like, show me the data. If the data, if the peer reviewed data in multiple models and in humans, RCT data is showing that they're efficacious, I'm going to be in the position that I'm okay with it. But it just doesn't, the odds of long-term survival are reduced for the most part with radiation when we're talking about the cancers that we're most interested in, and that's brain tumors. But
Yeah.
I think that could, kind of be applied to other cancers too, or most other cancers. So it's kind of a slippery slope. I've been in communication with people that have used radiation, they've recovered, they've used it with ketone metabolic therapy, and they're doing great. So, but they generally talk them into doing like lower dose or much, so it's usually a conversation that they have to have with their radiation oncologist. And I mean, there's forms of radiation, there's dosing. It's not like they did in the 1960s and 70s where they used massive amount of like radiation and hit. I mean, there's targeted forms of radiation now that are evolving, but I think it's still rather draconian if you
Yeah,
ask
yeah,
me. Yep.
yeah. I mean, I had the whole 9 yards. I had radiation, chemo, and finally surgery, and
Mhm.
luckily for me, the surgery was curative. But there we
Mhm.
go.
Oh, that's great.
But
Yeah.
looking at the Don, I mean, Don was used with it initially. It was injected with glucose. So of course
Mm.
that's not
Mhm.
going to be effective. And the glioblastoma model is, to me, the the number of videos that I've edited of Professor Seyfried's, and you talked about fast growing cancers and slow growing
Mhm.
cancers, and my thoughts, and it's just thoughts of a layperson, are that the different types of cancers that are more get more benefit from ketogenic the ketogenic diet, like you said, brain cancer.
Mhm.
The slow growing cancers, are they more glutamine dependent rather than glucose dependent? Because that seems to ring true from what I've seen.
Yeah, I mean, there are cancers. The heterogeneity is very diverse in different cancers, and the only way to answer that is to take a biopsy and then to do metabolomics or do tracer based fate associations, in different animal for different cancers. So, and then look to see where the carbons are going if you're feeding different substrates, for example, glutamine, radio labeled glutamine versus radio labeled sugars, or also radio labeled fats. So I'm of the opinion too that maybe even ketones. So I'm of the opinion that ketones are a very poor source of energy for tumor cells, especially tumors that have damaged mitochondria. And then the ketones too seem to have some the DL beta hydroxybutyrate, which is sold in some supplements. Keto Start is one of them. It seems to have some anti-cancer effects. So we've published on that with Tom's model, actually. So you would have to do like these tracer studies, but even with that said, if the ketones are not used as an energy source, or the glutamine's not used as an energy source, or any of these molecules, they could be used for the biosynthesis of the fuel. So they could end up, being incorporated into lipids and things like that.
Right.
So to answer your question, it depends upon the cell, the cell type of origin, if it has the capacity, to do that. And different primary tumors from different areas of the body have different capacities to measure to use glutamine as an energy source. One I guess simple way, but it's not too simple, is to determine if your tumor is highly metabolic for glucose, at least, is to do an FDG PET scan. And if a tumor is really hot on an FDG PET scan, that's at least a good indication that lowering insulin, lowering glucose, and elevating ketones, with a calculated ketogenic diet, is going to at least take the foot off the gas pedal of cancer growth, right? And then you can couple that with other therapies. But that's probably the best tool that we have, that people out there listening to this can be like, how do I know if my tumor is going to be responsive to? Well, if you're hot on a PET scan, yeah, that's a pretty good indication you're going to be responsive to metabolic therapy.
Yeah, that was my thoughts. That was when I first found out that prostate cancer doesn't light up a PET scan. So that's what had me thinking that it was more glutamine dependent than glucose dependent.
Yep. Mm-hmm. Yeah. Did you get like beam radiation or brachytherapy, or did you have, you mentioned radiation therapy?
Yeah. So my diagnosis was colorectal.
Okay.
So I had colorectal cancer, and so yes, I had a radiation chemo, and I don't know what type of radiation it was, but when I spoke to the surgeon afterwards, he said it hadn't really had an effect on reducing the size of the tumor for him to cut out. So he obviously did a good job and took a decent margin.
Mm-hmm. Yep.
So another question from our viewers, listeners, whatever we want to call them. How do you get into ketosis, and how do they get into ketosis and stay there?
Yeah, that's an ongoing question because, as you may know, which is, a big area of our interest, is the expanding applications of ketogenic diet therapy, right? So when I discovered Thomas Seyfried, when I basically just, went on clinicaltrials.gov, I think there was 2 clinical trials maybe, but now there's dozens, if not nearly 50, 60, maybe 70 government registered clinical trials So it's interesting to look through those protocols too to see what they're doing. And my concern is that many of them are not using a very optimal sort of protocol. But if you go to clinicaltrials.gov and just simply put in ketogenic diet, you get 400 to 500 registered clinical trials on using a ketogenic diet therapy. So one could actually, not that this is the best thing to do, one could actually go and look at the protocols to see what's being used from a research perspective for the ketogenic diet. So with that said, I'll tell you what we do, what I do. There are different types of ketogenic diets, right? You have, you could have you could just have a simple low carb diet, under, which actually would be under 100 grams of carbs, right? So,
Yep.
and then those carbs could be no sugar, no starch, and just, fibrous vegetables, basically. So that'll quickly lower your glucose for the average person eating, 300 plus 400 plus grams of starch and sugar based carbs. So that'll be a big needle. But it's important to ensure that protein make up about 20%, and that's higher than the clinical use ketogenic diets, which are more like 10 to 12 to 15. So I'm of the opinion that patients with cancer, if you're really reducing the carbs, should up the protein a little bit. And that protein should be spread out. Unless you are significantly overweight, then maybe you could do 1 or 2 meals a day. But if you're underweight, or stated another way, trying to maintain your lean body mass, it's important to spread out your protein with 3 meals per day. The researchers in protein like Donald Layman and Stu Phillips and other people who their whole career is protein metabolism would be of that opinion. They might say you could get away with 2 days per week or 2 times per day if you have a snack in the afternoon, which was something that I kind of do. So there's different ways to achieve therapeutic ketosis. There's Miriam Kalamian has a great book. It's called Keto for Cancer. And I think the guidelines in that book are fantastic. I also encourage, we think of ketogenic diets as a prescription metabolic therapy. So there's low carb, there's internet low carb, and then there's the ketogenic diet which is a prescription strength diet. So I say that because it does have side effects. If you implement it correctly with calculated, macronutrients, that you may not feel well when you start this because it's radically changing your metabolic physiology. So it would pay to work with a consultant. Denise Potter is an excellent consultant I'd refer. And she's expanded to have like 6 people on her team, and they have, they start with a template and then they personalize it to you. They're very good. So they've helped a lot of patients. So to read as much as you can, The Ketogenic Diet for Cancer by Miriam Kalamian will give you at least the background about macronutrients and about calculating them. And then you start with your base ketogenic diet based on the foods that you like, that are palatable to you. Of course, doing the carb restriction, but getting the fat in is typically hard for most people. So I like to incorporate medium chain triglyceride fats, MCT. Not everybody can tolerate MCT, but they don't taste like anything. So I make salad dressing out of extra virgin olive oil, half of it's extra virgin olive oil, half of it's MCT oil. And then I throw some herbs in there and I put it on, broccoli on salads and things like that. Sometimes vegetables are a good carrier of fat. So I think of vegetables as basically a carrier for fat, which is giving me extra calories to maintain my weight. Because if I don't get those fat calories in, I lose weight really, really fast. I'm trying to just maintain my weight at this point. So you want to get a well-designed, engineered, personalized ketogenic diet. And you could do that with a little bit of work. You want to measure your glucose and ketone in response to eating that diet. Most people find it hard to get the amount of fat that they need, so they can add MCT oil, which is cheap. You could buy a liter for 15, 20 bucks, and that's like, thousands of calories there. So the next phase to do is to use an exogenous ketone supplement. So what that will do is further elevate your ketones and lower your glucose to achieve and maintain that glucose ketone index. And that is like what I take, there's a couple products. So Keto Start is one. It has DL, beta hydroxybutyrate, and it's just combined with an electrolyte. So it's beta hydroxybutyrate combined with like sodium, potassium. It's got calcium, magnesium in it. You consume that, and these are electrolytes you tend to deplete more when you're on a ketogenic diet. So when people have like brain fog or they feel like a little bit low energy or lethargic, getting hydration and electrolytes can usually, 8 out of 10 times is kind of the response. So delivering electrolytes while you're delivering ketones is like, you get a double benefit there. So you have the diet, and there's different forms. We choose the modified Atkins diet or the modified ketogenic diet, which is more liberal in protein. The fatty acid composition, I'm in favor of monounsaturated fats, getting fat from also fish. The omega-3 fatty acids of fish have anti-inflammatory and anti-catabolic effects. So like today for lunch, I'll have a can of mackerel or sardines, or I have some salmon that I picked up from the store too. So fish is good. And, there are canned varieties of fish that are also very good that you can buy. I buy in bulk, especially when I travel. They're good. I like to eat fresh, but if I'm traveling, sardines are great. And then beef, grass-fed beef is probably, and eggs. Eggs are a superfood. So, support your local
Absolutely
farmers if they're selling eggs. And there is a difference between industrialized eggs and organic small farm raised. Luckily, our neighbors we have chickens, but it's hard to keep them with the coyotes around. But we have neighbors that have lots of eggs and chickens. So the diet, you want to get your diet on point, ideally working with a consultant, even it's for like an initial consultation of 1 or 2 hours just to set you up. Ketogenic fats, MCT, exogenous ketone supplementation, ideally in the form of, we do work with ketone esters. So they are very powerful, but they also need to be metabolized by the liver. And it does put some stress on the liver. Yeah, ketone esters are the more powerful form of exogenous ketones. They taste awful. They're expensive. They do have applications for things that we study, like military operations, but they're generally given in like one dose prior to, they're used acutely. Whereas, I have access to those things and I don't use them, if that says anything. So I have free access to ketone esters, and occasionally I'll experiment with them. But what I take on a daily basis is a ketone electrolyte. Keto Start by Audacious Nutrition is, the purest and most potent that I know. It has 10 grams as opposed to the other brands have like 3 or 5 grams. So I just take like a half of a packet. So one packet actually will last me a whole day. So I do Keto Start, exogenous ketones, typically first thing in the morning with creatine monohydrate. And that's a great supplement for strength and muscle. Creatine monohydrate is the most researched nutritional supplement that has ever existed. There's like 1,000, there's multiple randomized controlled studies using creatine, and it helps you preserve your muscle. There's anti-cancer effects of creatine that has been shown. So I do that. And you could occasionally, a couple times a week, I'll do time restricted feeding, which means I won't have my first meal till about 2 p.m, especially if I have a busy morning of teaching. But if I do time restricted feeding, or intermittent fasting is another term for that, if I do that too much, I start to lose weight and I start to lose muscle. So I think a big goal of a cancer patient should be to get your body composition assessed. That could be, we have an in-body system here in the US. You could do a DEXA scan. I do a DEXA once a year. But scale weight is okay. If you're monitoring your fat, you could do with calipers, but it's really important to just understand what your baseline body composition is, because I find that cancer patients over time can lose an incredible amount of muscle, and that muscle is directly proportional to your function, right? And they could lose a lot of muscle and correspondingly function and not know it over time. Like muscle wasting can occur incredibly fast. So it's just good to be cognizant of that and design your diet with an anti-catabolic muscle sparing effect in mind. And of course, the diet should be coupled with some form of exercise. you don't have to be deadlifting and squatting and bench press. You could do that, and they are big levers to pull for keeping your muscle. And muscle has an anti-cancer effect because muscle releases various myokines, and your muscle is basically an endocrine organ that releases substances that are anti-inflammatory, that can, prevent cancer cell growth. And your muscle is also the metabolic engine that makes metabolic therapies work, because that becomes your sink for glucose, right?
Yeah.
That helps you keep your glucose low, and it stimulates fat oxidation. And that accelerated fat oxidation is actually what drives your ketones up. So, it's really important to exercise is synergistic with diet, meaning that if you just did exercise for cancer or you just did diet for cancer, 1 and 1 equals 3, I guess, is the easiest thing to say. So when you couple the two together, there's a whole field emerging called exercise oncology. And they take patients that they don't even follow any kind of diet. They just exercise them, and they're getting remarkable results. So if you couple that with ketone metabolic therapy, then, that's a remarkably synergistic. So that encompasses what we're talking about as the press, right? And then there's pulse protocols, is kind of like a whole nother thing that we can talk about too.
Yeah. I mean, for anybody actually watching this video, check out my video with Jason Watson, who has worked extensively for himself and has 5 meals a day because he was wasting away, and he's a patient that's managed to get himself brought round, and he's now fully in metabolic homeostasis, shall we say, but he's also gaining weight, which is remarkable, really. Given what he's been through.
Yeah, putting on that muscle weight is really important. And I mean, it could just be walking. Walking stimulates the big muscles of the body. You want to take it up to another level. You could throw a backpack on with 10 pounds. We call that rucking, here in the US. It's like a sport. Rucking's like a sport. I actually do it because I'll go walk the dogs for about 2 miles a day, and I'll throw on like a 50, 60, or even an 80-pound pack if I'm doing a short walk, an 80-pound. And all that gives your entire body sort of resistance, and that can help really maintain muscle. I've seen older patients build 5 pounds of muscle just walking, just getting up and walking, especially if there's hills around their environment. They're adding muscle to the legs, and that's your metabolic engine. So that's really important to do that. And I think we don't talk about that enough when we talk about metabolic therapies for cancer. But also just getting outdoors and walking influences your brain. It has a psychological effect. It reduces stress. That's going to impact your glucose and all these things. So I think that's also a major factor too. Just meditation. There's things that people can do, being very in tune with your faith, and meditation, or just your community. That social network is really important, and you don't know that. So I have part of the research that I do is using continuous glucose monitors, and which I think you can get without a prescription in the UK. When you wear these things, that gives you incredible metabolic awareness of the environmental things, whether that be food, exercise, stress relieving, things that you could do. You're aware of how those things impact your blood glucose levels. Or with this, you're measuring interstitial glucose, which is a good correlate.
I approached a company that's actually, I was going to say in China, I suppose it is China now, Hong Kong, who are making a continuous monitor for both glucose and ketones. So that would be awesome if you could monitor your GKI level continuously, without having to do the finger pricks and the cost for people of the strips, which the ketone strips are actually quite expensive, aren't they? The glucose ones, and obviously, if you've got a glucose
Yeah.
monitor continuously, then you're okay with that.
Yeah, I would recommend. So a cheaper monitor would be the Keto Mojo, and there's the Abbott Precision Extra, but these are about half the price of that. So yeah, I'm aware of the different glucose and ketone monitoring systems, and I'm actually part of the Abbott study or group of people that's, the Abbott Lingo device can measure, ultimately it'll measure lactate, glucose, and ketones. But for me, I can't have it because I have an Android phone, and I think the software only works on the Apple right now. So they're working. The software engineers are working on the app for the Android. But with that said, I think continuous glucose monitors you could get. I know my students jump online and they buy them for $40 at like Costco without it,
Yeah,
and that's for 2 weeks supply. And I think they're going to get cheaper now that it just got approved last week for non-diabetics. So the market's going to increase, and these things are going to be like $10-15 for 2 weeks. It's going to be like $1 a day, basically,
yeah,
ultimately.
yeah.
So that glucose is really important. And then, you don't need continuous ketone measurement would be good, but if you measure it, once or twice a day, and you're eating the same things day in and day out, and you're on a routine, then you're going to know essentially, what your ketones are. There's breath ketone devices too. There's urine ketones. You could start with that.
Are they?
Just
Are
as
they?
like,
Are the breath? One question from one of the viewers was: are the breath ketone meters, are they any good?
there's a couple. There's one. So I've used different ones. Probably the best one is the BioSense. Readout Health makes BioSense. I understand that. I think the company may be under different ownership, and then the customer support may not be as good, but this is an FDA approved device. I had 6 of these, and I blew into all 6 of them, and they were all equal and they were all very equal. So some people claim they're not that, as reliable. I think breath ketones, if your breath ketones are elevated, you're in ketosis, but it's more like, relative levels. And I think in some ways, breath ketones may be a better reflection of true ketosis, because when you go on a ketogenic diet and your ketones become elevated and you're in a calorie deficit, your tissues are sucking out the beta hydroxybutyrate from your blood very fast. So you're in ketosis, but the ketosis that you're monitoring it's a ratio of ketone production and ketone utilization. And as you ramp up ketogenic therapies, you could be producing more ketones, but your metabolic tissue is pulling it out of the blood faster. Similar to like athletes, if you give them a glucose tolerance test, they clear glucose from their system very fast. I've observed that's what happens, especially in people that are very metabolically fit. And then the breath ketones actually seem to be a better reflection of physiological ketosis relative to the blood for some, because it's kind of like the ketones that you're metabolizing. And I think we're still trying to figure out there, but I think it's acceptable. I think the breath ketones are acceptable under any conditions. In some conditions, they could be favorable, especially if you're doing fasting or caloric restriction. But if I have to plug one blood ketone meter, I would plug the Keto Mojo device, is really good.
Yeah.
And a breath.
Professor Seafried, he talks about
Yeah.
the Keto Mojo all the time. Have you
Yep.
done any measurements of the Keto Mojo against a breath meter to see how
Oh
they
yeah.
relate?
Mhm. Yeah. So if you're on an isocaloric, basically, if you're consuming amount of calories that you're not in a surplus or a deficit, right? If you're not losing weight, your blood ketones correlate quite well with breath ketones over time, and that it's in parts per million. But then they have the company has their own ACE, their own units. So like one millimolar on a Keto Mojo would correlate to 10 ACEs on into a BioSense device. So, and I get up to 40 when I'm fasting for 3 days. My ACEs get up to 30 and 40, and that correlates to 3 and 4 millimolar for the Keto Mojo. What happens though, when I fast for 3 days, my ketones go up the first 24 and then they start to come down and they stabilize at about 2.5. But my breath ketones continue to go up, and it like maxes out the device.
Right.
So what I think is happening, and I'm speculating, is that my body is clearing the ketones from my system just due to being in an energy deficit. You have upregulated ketone transporters and ketolytic enzymes in a way that the level of ketone production is not correlating with the level of ketone measurement in the blood, because your blood is very adept at absorbing and utilizing the ketones for energy. Whereas the breath ketones tend to, there's an interesting dynamic there that I don't fully understand. And I've talked to this with Dr. Peter Attia. We've done some like experiment with fasting, and we're like almost bioidentical, like in our response in many ways. And I've communicated with many patients that experience this. So if you're doing like a prolonged fast, and for me, that's 3 days, like I don't go beyond that because it disrupts my hormones and things like that. I think the breath meter is fine. And you could blow into it 30 times in a day and it doesn't cost you anything, right?
Yeah.
So
Yeah.
you're not paying for strips. So it's kind of like a neat tool to have. And I use it. You got to stick it on, and then it takes like a minute to calibrate. So it's a little bit, if you're super impatient, you might find it a little bit frustrating, but I just push it and I do some work and it's calibrated. I blow into it and it's like, then I'll take my glucose measurements or ketone blood measurements.
Yeah, and I suppose if it was for someone that was not so well off, shall we say, it would be quite a good way to go, because they could use the breath meter 4 or 5 times a day and measure the with the Keto Mojo maybe twice a day or whatever.
Yeah. And I think it's great. My original interest in breath ketone measurements were that breath acetone correlated better with seizure control than urine or blood ketones. So there was some evidence for that. So in 2009 and 10, we're going back 15 years ago, I was like, oh, this is a great idea. And there's a couple companies that came out with prototypes, and they were a little bit cumbersome to work with. But the Biosense, the Readout Health Biosense, is kind of like a step function above those early devices by far. And I think it's also FDA approved. But for kids, especially kids that, you have a 2, 3, 4-year-old kid and pricking their finger is heartbreaking, right? When they don't want to do it. So a breath device where you can blow in and get a number, it's fun for them. Like it goes from something that they're absolutely scared to something that's like, oh, look at, try to get a higher number, and they get excited about it. So no, that's a great point. Actually, not something that I considered. But I've got 2 children. I'm saying I've got 2 children. I've got 2 grown-ups. I've got 31 and 29, I think they are. So yes, they are. But as when they were little, I wouldn't have dared, prick the finger. Yeah. So, especially my daughter. I've got the older son and the younger daughter, and my daughter would she'd kill me. She'd freak out. Another question. Have you heard of EWOT, exercise with oxygen? Yeah, I've heard of that. I think I saw there's actually a fairly sophisticated, expensive device for this that I saw, I think, in Arizona, maybe about 10 years ago, and they're developing this for metabolic therapy. I'm not sure, I haven't followed the company if it's commercially available. I like the idea. I would, enjoy testing it and maybe measuring different, biomarkers, blood or tissue over time. The theory seems to make some sense. I will say this, though, that, at resting conditions, your oxygen level is basically gets saturated because hemoglobin, the molecule that carries oxygen to your tissues, is called hemoglobin. And hemoglobin is typically saturated we're breathing 20 to 21% oxygen, right?
Yep.
At a bare I'm in Florida, so I'm at 1 atmosphere of pressure. If you were at if you're at altitude, maybe it would be a little more efficacious in delivering oxygen. But typically, most people who are not compromised have their hemoglobin is saturated. So that means that oxygen delivery to tissues is not compromised. When you breathe oxygen at an increased barometric pressure, the oxygen is delivered to the tissues independent of hemoglobin, meaning that it gets dissolved into the plasma. And when you dissolve oxygen to the plasma, it gets into all the little nooks and crannies that where the blood vessels, the red blood cells can sometimes impede blood flow to tumors that have erratic blood vessels, because the red blood cells get caught into the tiny capillaries that are growing erratically. However, when you saturate the plasma with oxygen by increasing the barometric pressure, then that's the big lever that you pull to reverse tumor hypoxia. I'm not convinced that breathing 100% oxygen, and then I think that's what maybe the EWAD, enriched oxygen. However, in theory, you could titrate in carbon dioxide, and carbon dioxide is a vasodilator. And I've always been interested in this idea. I have not tested experimentally for cancer, but we study it in the context of oxygen toxicity, because if you titrate in a little bit of carbon dioxide, it makes oxygen toxicity happen faster. In theory, if you were to breathe a little bit of carbon dioxide, that vasodilation effect could hyperoxygenate the tumor. And that could be something that could be employed with normobaric hyperoxia, in theory. So, and I think maybe some people, I mean, this is an idea I've had for 20 years, but, and I've thrown it out there for people to kind of bite on it. And, and it's also called carbogen, carbogen. So carbogen's like 95% oxygen, 5% CO2. I don't think you don't need like 5% CO2, which is a pretty big hypercapnic hit, but you could titrate in, 1% oxygen or maybe 2% or something like that in theory. And then that would make that more efficacious. I don't know if they've thought about that, but I'm throwing that out there for someone to pick up on that.
Yeah. The HBOT that I actually manufactured one when I was suffering myself with cancer, and basically it was an oxygen machine, the type that a patient would wear, that was suffering with
COPD or something like that.
Yeah. I'm trying to think what it was that my mum had when she was alive, and she had one of these oxygen machines, and it takes the oxygen out of the air, purifies it, and pumps out something like concentrated 95% oxygen. And the idea was that you get a big bag and fill it up with the oxygen, and then wear a mask like a face mask, with the pipe going to the thing, and then get on a treadmill and run on the treadmill, or ride a bike, one of these stationary bicycles or something like that. And I just wondered if you'd come across that, and obviously from what you've just said there, it's not going to be anything like as efficacious as hyperbaric is, because of the whole hemoglobin thing.
Yeah, but I think it makes, I mean, if you're blowing into the bag, then there's a little bit of dead space going on there. So it could be, you could also be increasing the level of CO2, and that may not be a bad thing, because that CO2, there's something called hyperoxia-induced vasoconstriction. And under normobaric hyperoxia conditions, that could potentially mitigate some of the beneficial effects of high oxygen. So titrating in a little bit of CO2 in the scenario you described could be efficacious. But nonetheless, I mean, what you're talking about is breathing oxygen. It would be interesting to measure your oxygen concentration. So just doing one of those little finger measurements of looking at, the optical measurement of hemoglobin saturation could be useful. And hey, and if that improves 1 or 2 or 3%, then you're getting a benefit.
Yeah. Actually, your outgoing air doesn't go into the bag. It's a two valve mask. So you're breathing in the oxygen and then breathing out the CO2 through a different valve. So so you wouldn't be putting the CO2 back into the bag.
That's right. Yeah, I think I knew that. Yeah, that's right.
Yeah, yeah.
But in theory, I think it could be, but you'd want to, if it's not too cumbersome and everything, it's not like a big expense maybe, but to just simply measure, just do a little pulse ox and just measure your oxygen saturation and see if that improves, then you're getting benefits from it. Of course, if someone's compromised with COPD or some kind of respiratory insufficiency, then supplemental normobaric hyperoxia can be beneficial. But you also run the risk of what's called pulmonary oxygen toxicity. Like if my room here was just replaced with 100% oxygen and you kept me in here for 2 days, I would be dead.
Right.
Because the high oxygen environment, I don't think most people maybe don't know that. You don't have to have hyperbaric oxygen to have oxygen toxicity. You're not going to get CNS oxygen toxicity. You're not going to have seizures, but the partial pressure of oxygen increasing independent of increase in barometric pressure will cause pulmonary oxygen toxicity.
Right. Yeah. I'll just have a quick look through the forum, see if there's anything that we've missed. Don and the part of the pulse. Denise Stacy that I mentioned earlier, that was N of 1, who had the arterial sarcoma. He had all of the things on board. So he had the Don on board. He had obviously the press was 2.0 and below. I think it was below 1 at some points, and also had other substrates on board, metformin, to also help lower his blood sugar. So you would recommend to have all of those things on board when doing the hyperbaric oxygen to give the greater cancer killing effects, shall we say?
I'm a little bit hesitant because I think when you start adding a lot of things, then you can have effects that there's knowns and there's unknowns and there's unknown, So when you do that, so I've communicated with patients over the years. I'm trying to think of examples, but dichloroacetate, DCA. So DCA has a pretty good track record. We've studied DCA in our lab with and without metformin, and actually we see some synergy with metformin. Actually, we use Dr. Seyfried's model, the VM-M3 cells, to do that. However, I'll say I have communicated with patients over the years that use DCA, and there are a number of registered clinical trials on DCA, probably over a dozen now, because I think that the mainstream cancer community agrees that it's an off the shelf, it's pennies per dose. It's a very cheap drug, but it's actually can be quite effective for cancer and synergizing with other therapies. However, and I'm just giving this as one example, when patients use DCA in pharmacological therapeutic levels, within many patients over the course of a month or two will get peripheral neuropathy because it increases an enzyme called pyruvate dehydrogenase complex, and that complex requires very high levels of vitamin B1, which is also called thiamine. And
Right.
if you deplete your body of thiamine, then this kind of triggers a peripheral neuropathy that reverses in about 2 weeks. So the idea that actually put a seed in my brain of like, okay, some things are better used in a pulse protocol. So one of the things that I sort of thought about, in way before we actually published the pulse protocol, was that certain things need to be pulsed. And I think hyperbaric oxygen could be done 3 weeks on, 3 weeks off. DCA, 3 weeks on, 3 weeks off. Maybe even IV vitamin C, 3 weeks on, hit it hard, 3 weeks off. And maybe they could be staggered in ways. Not IV vitamin C may synergize with the hyperbaric oxygen. The point is that when it's done, anything that has a potential for side effects, cumulative side effects like DCA, should be cycled 3 weeks on, 3 weeks off. And that's we're at the nascent stages of figuring out the dosage, the timing, and the scheduling for this. So that press pulse protocol that was published, I'm trying to think now, maybe 2017, quite a few years ago. But the review that's coming out, I think may add to that. And I think one way to, I wish we had a biomarker for hyperbaric oxygen, toxicity or whatever that we could measure. There's a couple things out there. HSCRP, if you see that climbing, so if you see HSCRP climbing over the course of, your hyperbaric, and you're doing 5 days a week, that's actually a good indication to drop down to like 2 days a week. But the press protocols would be therapeutic ketosis, ketone supplementation, exercise, meditation, getting a GKI maintained into 1 to the 4 range, and then pulse protocols, hyperbaric oxygen, and then metabolic drugs. Put under that DON, DCA, even metformin, I think can have, you could use perhaps 500 milligrams a day and then pulse it up to 2000 milligrams a day,
Mebendazole, febendazole.
Mebendazole, yep, exactly, yep. So those drugs do have, metabolic therapy is not without potential for side effects. So they're just less than chemotherapy, and the side effects, unlike chemotherapy and radiation, the side effect, if you were just take a healthy person and give them chemo and radiation, then that is a powerful carcinogen. So the metabolic drugs associated, that has side effects, their side effects are generally not associated with a carcinogenic effect. They could have the opposite, a very strong anti-carcinogen. But anything that's really toxic over time is potentially toxic to the mitochondria and can be.
I did an interview with a guy from Britain called Shane Clark, and if you were to watch the video, we're both from the same sort of area of the country, so we go into our accents. So you Americans would find it difficult to understand. I have a friend that lives in Ohio, and we've been talking on the internet since it was born, and even now he still struggles to understand me at times. But Shane Clark came onto the channel, and we had a discussion, and he's now NED, and he had what did he have? He had, I think it was liver cancer, and I think it went to his lungs, and whatever it was, the oncologists knew that it would go to his lungs, and so it was a particular type, and that's where it metastasized to in most patients. And he'd had the standard of care, and it had obviously not worked, and it knocked the plug out of him. But he read a story somewhere on the interwebs that mebendazole cured cancer, and so as a Northern English manual worker, he just went down the route of taking mebendazole. But the other thing that he read was to also take L-glutamine, and so his protocol was mebendazole and L-glutamine, and his cancer went away. And from everything that I've learned about Professor Seyfried and the theory that cancer is a mitochondrial metabolic disease, that makes no sense whatsoever. The fact that he was taking L-glutamine, and the only explanation I can think of, and I wondered if you might think of anything else, was the fact that the L-glutamine enhanced his body's ability to deal with it and increase his immune system in some way, shape, or form.
Yeah, here's what I'll say. When you take oral glutamine, it can enhance your immune. About 70% of your immune system's in your gut, right? When you take oral glutamine, the blood levels of glutamine don't really change all that much. It goes through It gets absorbed. It gets mostly absorbed and metabolized in the gut. The gut has a remarkable ability to use glutamine as a fuel. So, but some will get into circulation. So it'll go via hepatic portal circulation to the liver. Then the liver will use, some of it for energy. Glutamine is a conditionally essential amino acid, meaning under periods of stress, it can be beneficial to maintain immune status, especially conditions of muscle wasting. Burn victims use glutamine. It can help repair and restore the gut, especially if you have a leaky gut. So a leaky gut causes inflammation. Taking glutamine can help restore the intestinal mucosa to the point where it can reduce gut permeability. And by reducing gut permeability and also glutamine as a source of fuel for the immune cells, it can repair the immune system. And there's some discussion, and I believe this too, that it could, by enhancing the immune system, the number of natural killer cells, make the immune system more vigilant against identifying and neutralizing cancer. So making your immune system more robust. A ketogenic diet has been shown to enhance the adaptive immune system, and there's studies and quite a bit of interest now. And it can do that in just 2 weeks. So it changes blood markers of your immune system, showing a robust increase in adaptive immune system that can, for example, make checkpoint inhibitors like PD-1 inhibitors more efficacious. So mainstream medical oncology, centers now have an interest in the ketogenic diet, not so much because it's targeting the tumor, but because it's going to make their drugs, especially this newer class of drugs, the checkpoint inhibitors, much more effective. So, evidence of that is 2 big groups reaching out to me from Moffitt Cancer Center saying, okay, we're interested in the ketogenic diet now because it shows there's a really good rationale that it's going to enhance immune-based therapies. So, I don't know what diet he followed, but it's along those lines of, if you enhance and help the immune system out, then part of the hallmarks of cancer is failure of the immune system to sort of recognize the tumor. And that's due in part to the Warburg effect. Dumping lactate and acidifying the microenvironment makes it harder for the immune system to recognize the cancer. So by virtue of changing the diet to reduce glucose and also insulin drives glycolysis, which increases lactate production. Other researchers in the past have been thought about dumping sodium bicarbonate, but what's the source of the lactate, right? That is glucose. So you just reduce glucose consumption, and the ketogenic diet will suppress insulin, and that's really the driver of glycolysis and lactate, right? So the tumor will be dumping out less lactate, and it's not acidifying the microenvironment, which then prevents the immune system from recognizing it. So, but in theory, you bring up a good point. With the glutamine's a big topic, and I've been in discussions on either side. And I think it's really context dependent, and it really depends on the type of cancer and the patient, if they have compromised immune system, if their gut is completely knocked out because of, chemotherapy. It might be super important to just throw in 5, 10, 30 grams of glutamine just to repair the gut.
Yeah. If they've eaten nothing but pizza and French fries and McDonald's and for their whole life, their gut is going to be compromised, isn't it? When they've lived basically off sugar for all the days. And the Press Pulse protocol with Don, for example, I do wonder whether it might be worth in the week off. So it's glutamine on day 2, day 4, day 6, day 8, or whatever. I'm thinking off the top of my head now. That's not exactly Dennis Stacey's protocol. It is on makecancer.com. But if let's say that's what you do, they do 2, 4, 6, 8, 10, 12, and then you take 2 weeks off the Don, then maybe it might be worth taking L-glutamine to help your immune system in that that period of time. That would be interesting to see those experiments done.
It may be, but I'm of the opinion to let the biomarkers drive that decision. So if you do a comprehensive metabolic panel and a CBC, and I have lots of different patients, have reached out and they send me their blood work, and then based on the blood work and their tumor markers, their red blood cells, white blood cells, and it's important to make that decision based upon if you do not see evidence of a compromised immune system. If you do not have evidence of overt evidence of gut permeability, one evidence of gut permeability could be, I think, one of the biggest evidence is elevated CRP. Can be. I mean, there's many different reasons if you have infection, but for example, like within a few hours of getting feeling a gut bug come on and feeling my stomach like wrenching and stuff. And then the next day, if I was to do a blood measurement of HSCRP, which I've done occasionally, I have a home kit for it.
Yep.
My HSCRP is usually non-detectable or 0.1 or 0.2, but I've had a gut bug. Sometimes I'm traveling. Last time I remember we were in Asia. Man, it was like HSRP was off the charts, So your gut is really that barrier, serves as the most important barrier from the environment to your body, right? And if you're letting things through, and I'll say that glutamine has a remarkable ability, as does beta hydroxybutyrate, which I mentioned, the keto start product. Butyrate goes through circulation, and then that becomes an important fuel for the colonocytes and for the gut. And also soluble fiber.
Please send us
too.
Please share a link, and I'll put links on the video.
Yeah, sure. So, and I think these things are important to repair and maintain, reverse gut permeability, and to maintain that gut, because the gut. I mean, I teach this topic to the medical students, and the gut is that's like your biggest barrier, and if that's compromised, that triggers a cascade that can trigger autoimmune reactions. And then if your body's trying to neutralize stuff that's getting into the blood from the gut, then it has a crippled capacity to target the cancer. So impaired immune system then leaves the gates open for cancer too. We're all like cancering, we have, precancerous cells can develop, but a failure of our immune system to recognize it is when those cancer cells get seeded in a certain area, they start growing like crazy. But immune surveillance through immune optimization, through the gut, through just healthy lifestyle, exercise, is super important too for the gut. We don't think about that, but it really is. Hydration, electrolytes.
I was amazed at what you said there about before when you mentioned exercise. Walking around with a backpack on. And morbidly obese people that have been diagnosed with cancer, get off your fat butt, and as you Americans would say.
Yeah. And a little bit goes a long way. I mean, you can just wear a continuous glucose monitor, and a 10-minute walk after your evening meal can basically make it look like you didn't even eat anything. It's like, it's remarkable. So a little bit goes a long way. Start with a 10-minute walk. Do that, once a day, ramp it up to twice a day, 3 times a day. And then we like to do, yesterday I was mowing the lawn with a big walk behind mower, and I did 2.5 hours of walking. So that's unusual for me. But usually I try to do about an hour of walking each day. We have dogs, so it kind of, they make it non-negotiable for me. They will, they make sure I get in my steps for the day.
Yeah, I'm the same. I've got a German Shepherd and a Border Terrier. Mm-hmm. And guess which one's the boss? The Border Terrier.
Oh yeah. I have a Great Dane and a Black Lab, so 2 rescue dogs.
All right, wow, yeah. Great. I mean, Great Dane's huge, but the Labrador, a Labrador doesn't wag its tail; it wags its whole body.
Yeah, it does. Yeah, it gets excited when I get home. Yep.
Yeah, they go absolutely crazy. Dom,
my dogs eat what I eat. So I have the, steak and eggs this morning, and they have steak and eggs this morning. So people always ask me like what to feed the dogs. I was like, well, your diet should be on point, and your dog should be eating essentially the same diet. So.
I mean, yeah. Let's face it. I mean, canine. They have those canine teeth for a reason. I mean,
Yeah.
Ripping flesh off of stuff.
Yeah.
And all dogs are descended from wolves. And
Yeah.
have you ever actually seen
omnivorous
a wolf?
carnivores? I think I would say they're omnivorous carnivores. Like they can eat. They can go outside of a carnivore diet, but I mean the core of their diet should be meat and organ meat and things. So we give them liver and heart, and we have a cow. I just butchered a cow. It got struck by lightning right outside my window, so I had to butcher it. So we've been eating that, and the dogs eat one of our cows. Yeah, we kind of live off the land here where we're at.
Yeah. Wow, amazing.
Great. Well, thank you, Vincent. Yep. I appreciate your time, and I appreciate your attention, and getting more exposure to this too, to everybody out there.
Absolutely. I'm just trying to save the world here. Literally.
That's more important. That's in many ways more important than being in the lab doing research. Like if you could publish all the research in the world, but if people don't hear about it, that's education outreach.
Yep, I'm really looking forward to Grok. The artificial intelligence thing on X, or
I use it.
Or any of the other ones. Actually, being able to read the whole of PubMed, for example, and ask a question and get the answer from the papers, and I think that'll come, and that'll really help as well.
We live in an amazing time, and hopefully these AI systems don't bias it towards one way or another. Hopefully they just take, but it's really important for us as scientists to publish as much as possible, inspire young people to get into this path so they can help us, but also take time like you're doing, like, we're both doing for education outreach to get the information out there.
Absolutely.
And I thank you for that.
Thank you. Dominic, brilliant. Thank you.
My pleasure. Thank you.
Cheers. Bye.
Bye-bye.